This is 6.1a of geometry. So we've got a theorem here, 6.1, called the polygon angle sum theorem. It says the sum of the measures of the interior angles of an n-gon is n minus 2 times 180. An n-gon is a polygon with n sides. So a polygon with 4 sides, a polygon with 5 sides. You'd plug in 4, you'd plug in 5. And so a triangle is one of those, and we know that a triangle has 180 degrees inside, right? And the interior angles, so the inside of the triangle, it adds up to 180. So if we test that out and we plug in 3 minus 2 times 180, well, 3 minus 2 is 1. 1 times 180, that's 180. So there's 180 degrees inside of a triangle, which we'd agree, right? We've said that before. Over here to the side, I wrote out a couple of names of n-gons. So if there's 4 sides, it's called a tetragon. If there's 5 sides, it's called a pentagon. 6 sides is a hexagon. 7 sides is a heptagon. 8 sides is an octagon. 9 sides is a nonagon. And 10 sides is a decagon. Okay, so finding a polygon angle sum. Let's jump down to our got it problem. It says, what is the sum of the interior angle measures of a 17-gon? So, we're going to plug in 17 to our n minus 2 times 180. So this is 17 minus 2 times 180. And 17 minus 2 is 15. So this is 15 times 180. 15 times 180 is 2,700 degrees. So there's 2,700 degrees inside a 17-gon, a polygon that has 17 sides. Okay, an equilateral polygon is a polygon that all the sides are congruent. An equiangular polygon is a polygon with all the angles congruent. And a regular polygon is a polygon that is equilateral and equiangular. All the sides are congruent and all the angles are congruent. Okay, the corollary to the polygon angle sum theorem. The measure of each interior angle of a regular n-gon is n minus 2 times 180 divided by n. So the key thing here, a regular n-gon. Remember we just said that a regular polygon is equiangular. All the angles are congruent. That's why we can use this. This top bit up here, that was our angle sum theorem. We said the angles inside of a polygon, an n-gon I should say, add up to be this much. Well, if a polygon has n sides, it also has n angles. So when we divide it by n, we're dividing by the number of angles, and we get how much each angle should be. So let's say we're looking at a polygon with 12 sides. So this up here, when you plug in 12, would get you your total for the angles inside. And then we divide by 12 because there are 12 angles in that polygon. And so that would tell you how much each of them is. Again, let's try that for the triangle. So it'd be 3 minus 2 times 180 over 3. An irregular triangle would be a triangle that has all congruent sides and congruent angles. And remember, that would be an equilateral triangle. And we said that equilateral triangles have congruent sides, congruent angles, and each angle is 60 degrees. So we want this to come out to be 60. 3 minus 2 is 1, so we've got 1 times 180 on top, which is just going to be 180. So we've got 180 divided by 3, which is 60. And so it works. Okay, look at this housefly. It says the common housefly, I can't pronounce what its actual name is, has eyes that consist of approximately 4,000 facets. Each facet is a regular hexagon. So a fly's eye is made up of 4,000 hexagons, regular hexagons. So you can figure out the measure of each interior angle in one hexagonal facet. I hope I'm saying that right. So a hexagon has 6 sides. So we would use our equation, plug in 6, and each angle then is 120. Okay, let's check out our got it problem. What is the measure of each interior angle in a regular nonagon? Do you remember which one was a nonagon? That was a polygon with 9 sides. So, n minus 2 times 180 over n. I'm going to plug in 9, so 9 minus 2 times 180 over n, which is 7 times 180. Oh, oops, I can plug in 9 over here for n. Over 9. 7 times 180 gives me 1,260. So remember that top bit tells me that the sum inside of this polygon with 9 sides, the sum of the angles is 1,260 degrees. And when I divide by 9, that tells me how much each angle is, and that is 140 degrees. So each angle inside a nonagon, a polygon with 9 sides, is 140 degrees. And there's your homework.